Hello students, today we are going to study the three orthogonal coordinate system and three system what we are going to see today is rectangular, cylindrical and spherical coordinate system. Before seeing what is different types of coordinate system, let us see what is coordinate system itself. A considerable amount of work and time may be saved by choosing a coordinate system that best fits the given situation. A hard problem in one coordinate system may turn out to be easier in another system. So there are many coordinate systems, not only the three, there is Cartesian, spherical and cylindrical. Still more coordinate systems are there. And once again, there may be an orthogonal coordinate system or non-orthogonal coordinate system. Even then, some problem which is trying to be difficult in one coordinate system will become very easier when it transferred to the next coordinate system. So we have to choose the proper coordinate system to solve the particular situation problem. So in general, the physical quantities dealt in electromagnetics are function of space and time, because all the quantities which are dealt in electromagnetic theory are in the space. So they are the function of space and time. In order to describe the spatial variation of these quantities with respect to space and with respect to time, it must be able to define all the points uniquely in space in a suitable manner. How to define each and every point in a space. So for this we need a appropriate coordinate system. So coordinate system, a point or a vector which can be represented in curvilinear coordinate system, may be an orthogonal coordinate system or non-orthogonal coordinate system. What do you mean by orthogonal coordinate system is in which all the coordinates are mutually perpendicular to each other. The angle between two coordinate axes will be 90 degree. And for non-orthogonal system, these conditions will not be mutually perpendicular to each other. But it is somewhat hard to work with and they are of little and of no practical use. So today we are going to see only the orthogonal coordinate system. So these are some of the examples. There are still more orthogonal coordinate systems are there. So here I have listed 9 systems here. Out of the 9 systems, in your syllabus you are going to study 3 coordinate systems. So the first one is a Cartesian, circular, spherical, elliptical cylindrical, parabolic cylindrical, conical, prolate spheroidal, oblate spheroidal and ellipsoidal. So you can see the first one, the Cartesian coordinate system. Here there are 3 axes x, y and z. In cylindrical coordinate system, see here it is a cylindrical cylinder-like structure. The axes are, one is the center axis which is z, and another one is the radius which is r, and another one is the angle in the circular section, so it will vary from 0 to 180. Likewise, it's a sphere. So we are going to study these three in detail. And fourth one, elliptical cylindrical is here. In elliptical cylindrical, we can see the diameter is in horizontal axis is large compared to the center axis height. This one is a parabolic cylindrical, and this one is the conical type, and this one prolate spheroidal, and this one oblate spheroidal, and this one ellipsoidal spheroidal. So today in this session we are going to see the rectangular coordinate system. So here in rectangular coordinate system, there are 3 axes which are x, y and z. So in this, the x, the first coordinates x will vary from minus infinity to plus infinity. The lower limit is minus infinity and the upper limit is plus infinity. Likewise, we can see for y-axis and z-axis, these 3 are the limits. How to write the coordinate, how to write a vector in this coordinate system is given by ax into ax vector. Small ax stands for vector, ay into ay vector, and az into az vector. Here capital AX, capital AY and capital AX are the components of AX vector, AY vector and AZ vector, and these 3 vectors are unit vectors directed along X, Y and Z direction. So for clear understanding of the coordinate system, Let us look into video. You can see in detail. So this one is a spherical coordinate, cylindrical coordinate. For clear understanding, we are seeing this one is the coordinate system, Cartesian. So first let us see a single dimensional coordinate system in Cartesian. So there is only one axis, which is x-axis. So you can give the unit. This one is a reference. In mathematics, you have studied in number line. So 0, 1, 2, 3, and in the either side it will be -1, -2, -3. If you want to locate the point A is equal to -1, see here. A single value is enough to locate a point. This one is the origin. If it is an x-axis, only one value is sufficient to locate any point. If you want to locate this point, you can specify as 2.5. If you locate 2.75, you can locate here. There is no such confusion. So this right hand side will be a positive axis and your left hand side will be a negative axis. This will end up to -infinity. This will also end up to positive infinity. Likewise, you can point out many points. Even you can find this one is 1.5 means this one will be 1.25. Likewise, you can find out any numbers. Now let us see the two-dimensional coordinate system. Here, if you want to locate any point, we need two values. Single values is not at all sufficient to locate any point in this system. So this one is the x-axis and this one is the y-axis. This one is the origin. This will be a positive x-axis. This one will be the minus x-axis. This one positive y-axis and minus y-axis. Now if I want to locate any point in a space between x and y-axis, we need two values, x comma y, where x is this horizontal value and y is this vertical value. That's this one. The x-axis is also called abscissa and y-axis is also called ordinate. In this coordinate, in this quadrant, we can say the both the values x value and y values are positive. In this quadrant, there will be a minus x value, but y value will be a negative, and here both the values are negative. Once again here x-axis will be negative and your y value will be a positive. So it is 2, 2. You can see here if both the values are positive. Here this point is -1, 1. So x value alone positive. Here both the x value and y value are negative, -2, -3, 1, -1, -2, and this one -3. Here -4 stands for x-axis. So positive x value and negative y values. So always it is numbered as this one is the first quadrant and second quadrant. This one is third quadrant. This one is because in electromagnetics we should know how to deal the space, how to locate each and every point. That's why it is clearly explained in the Cartesian coordinate system. Both whatever I said is explained here. This will ranges up to -infinity. This one +infinity. Once again, this y-axis also ranges up to +infinity, and minus y-axis will also extend up to -infinity. So both the values have so totally two datas r cross r, and r has the same set of values, and y and this r also has the same set of values. So now this is the most important, prime important three-dimensional. So you can see here, this one is x-axis, another one is y-axis, that third one will be the z-axis. The angle between z and y will be 90 degrees, and y and x also will be 90 degrees, and x and z is also 90 degrees. You can imagine, and out of these two lines are horizontal. You can imagine like that, same plane. Just imagine in the 3D view. So just same thing represented in 3D. You can see here it is 90 degree. So this one minus axis, plus axis, plus axis, minus axis, positive. This one is a negative. Likewise, same thing here, x, y, z, both the three axes will ranges from plus infinity to minus infinity. If you want to locate any direction, take your right hand. See, you can hold the finger. You can hold the axis, vertical axis. The pointer will point in the upper direction. So which is pointing in the upper direction will be the positive axis. So now you can understand the 3D view better. The previous one, see here, I can repeat here. So see here, this is a plane. Here in this plane it is represented by x and y, and throughout this plane z value will be constant. For different z values you have many set of planes. Can you understand this plane? This is one plane x. This plane is represented by x and y. Let us see the next plane. Likewise you have the three planes, and this one. This plane you can understand here, this is z value, and this one will be the y value. You can understand here, and throughout this value the x value will be going to be constant. Throughout this plane x value will be the constant. So this one is the second plane. And now you can see here also z is varying and x is varying from 0 to minus infinity to plus infinity, whereas your y value here, y value for each line same y value. So here y is constant. So likewise you have three set of planes. So the three set of planes are represented here. XY plane starting, this one y is a plane, and this one x is a plane. Now you can see in top there are 4 quadrants, and bottom also you have 4 quadrants. You can clearly understand 1, 2, 3, 4, 1, 2, 3, 4. And which one is the first quadrant? All the values are positive, that one is the first quadrant. So it is see in all the faces, left side or right side, top or bottom, in all the sides you have the 4 quadrants. 4 quadrants. So totally you have 8 quadrants in the 3-dimensional system. In shortly we can say 2 power 3, 8 quadrants. So if now I am going to locate a point in a space, you can imagine a space here. Single, so if it is single dimension, it is enough. You have a line. 2-dimensional, you have the this one. 2-dimensional, we have the plane, and for 3-dimension you have to locate any space. Now we are going to locate a point here. So for this point you need x, y and z values. So x value this much, that is this much value, x value, and your value from origin, how much value you have to move, it's going to be y, and for z, how much value it has to started from here. Just you imagine the started line in the plane. So now you have located here point x, y, z. 4, 5, 3 means your x value is 4. See here, this 4. Then you have to locate 5. From origin, you have to take 5 points. And for z, from this origin, you have to take 3 values. So now, since all are located in the same plane, in this also agree. I think you will understand now very clearly. இது வந்து ஸ்பேஸ் மைன் நினச்சிக்கோங்க. இந்த குவாட்ரண்ட்டில் இருக்குது, இந்த குவாட்ரண்ட்டில் யூஸ் பண்ணுங்க. நடுவில் அடைச்சிச்ச மாதிரி யூஸ் பாருங்கள். கேன் சி இதுவும் 3 தான் இருக்கும். இங்கேருந்து இந்த பாயிண்ட்டு 3 தான் இருக்கும். இதுவும் 3 தான், இதுவும் 3 தான். 3 டைமென்ஷன் நல்லா இமேஜின் பண்ணி பார்த்துக்கோங்க. ஹியர் இந்த குவாட்ரண்ட்டில் பாருங்கள் 4 - 6 6 மீன்ஸ் y value alone ஒரு axis மட்டும் நெகட்டிவ், ரிமைனிங் 2 axis பாசிட்டிவ் ஆகும். Likewise, they located for 8 quadrants. Now you can see here 3 quadrants. இங்கே ஒரு quadrant. இந்த பாயிண்ட்ஸ் வந்து லொக்கேட் பண்ணுறாங்க பாருங்கள். ஸோ இந்த குவாட்ரண்ட்டில் கீழே உள்ள குவாட்ரண்ட் பார்த்திங்கன்னா இந்த ஆக்சிஸ் மட்டும் நெகட்டிவ் இருக்கும். மேலே வந்து இது பாசிட்டிவாக இருக்கும், இதுவும் பாசிட்டிவ், இந்த வேல்யூ நெகட்டிவாக இருக்கும். இந்த குவாட்ரண்ட்டுக்குள்ளே இது மூணுமே பாசிட்டிவாக இருக்கும். அந்த மாதிரி யூ கேன் அண்டர்ஸ்டாண்ட் 3Dயில் எப்படி லொக்கேட் ஆகிருக்கு. ஸ்பேஸில் ஒரு பாயிண்ட்டை லொக்கேட் பண்ணோம்னா 2 வேல்யூஸ் வந்து இட்ஸ் நாட் அட் ஆல் எனஃப். சி ஹியர் 2, இப்போ சப்போஸ் XY வேல்யூ கொடுத்தா இதுலேருந்து 2 வேல்யூ தான் கிடைக்குமே தவிர இன்னொரு பாயிண்ட் வந்து தெரியாது. we don't know where to locate, so you need 3 points to locate any point in a space. இவ்வளோ இன்னும் கொஞ்சம் நல்லா கட் பண்ணி பாருங்கள். ஃபஸ்ட்டு குவாட்ரண்ட்னா எல்லாமே பாசிட்டிவாக இருக்கும். இந்த ஆக்சிஸும் ப்ளஸ்ஸு, இதுவும் ப்ளஸ்ஸு, இதுவும் ப்ளஸ். ஸோ வாட் எவர் த பாயிண்ட்ஸ் லொக்கேட்டட் இன் திஸ் காலம் வில் பி பாசிட்டிவ். ஸோ ஹியர் இந்த பார்த்தீங்கன்னா இது மட்டும் நெகட்டிவாக இருக்கும். இந்த இடத்துல 2மே நெகட்டிவ். இந்த போர்ஷனில் பாருங்கள் இது மட்டும் நெகட்டிவாக இருக்குது. ஸோ இந்த குவாட்ரண்ட்டுக்கு நேராக கீழே டோட்டலி 8 குவாட்ரண்ட்ஸ் அவங்க லொக்கேட் பண்ணிட்டாங்க. ஸோ எந்தெந்த குவாட்ரண்ட் எந்த பாசிட்டிவ் நெகட்டிவ்னு எனக்கு கிளியராக. ஸோ ஐ திங்க் யூ ஹாவ் த பெட்டர் அண்டர்ஸ்டாண்டிங் ஆஃப் தி Cartesian coordinate system presented here. And once again, all the 3 axes will vary from plus infinity to minus infinity. All have same set of points. For x-axis also, y and so in short we can say it is an R cube, and the R is a subset of x comma y comma is, and these all the values will be an element of real numbers. So next comes the cylindrical coordinate system. Likewise, in Cartesian coordinate system, we will see the cylindrical coordinate system in detail in the next class. If you have any doubt, you can comment in the section. Thank you.